So in the last class we had talked about DFS. Okay. We had talked about the completeness, we had talked about optimality, we had talked about time complexity and space complexity. Any questions until what we had done in the last class? Any questions in this? All right, so we continue. So we had seen that the time complexity is order b to the m. It is actually order b to the m plus 1, but b to the m is already very high. Only has siblings on paths, so this is also we had seen, and we had talked about these two things as well. Now we talk about BFS. So remember this cartoon on DFS. For DFS it is like we are just going in depth, and for BFS it is we are going level by level. Okay. Now, so since you have seen DFS, can you help me figure out what will be these quantities, what will be these properties for BFS? Is BFS complete? Is BFS complete? What does completeness mean? If there is a solution, then if there exists a solution, then completeness implies that we will be able to reach there. Is that true for BFS? Yes. What about the other thing? Optimal? Is BFS optimal? No. But if I ask you, in which case, give me a condition such that BFS is optimal? सोचो, दो सेकंड सोचो. Easy, very easy to figure out. So let's say in general this one is the most optimal, the optimal one. Okay. In which case will this guy be the optimal? Chalo, we'll talk about it, but it's easy. हो सकता है by the time we reach there you will be able to figure it out. So in BFS again, what was our original strategy? अपन original algorithm में कर क्या रहे थे? You are given a state space, you are given a state space, right? You want to convert it to a search tree. इस search tree में आप क्या करोगे? You are supposed to expand nodes in this search tree until you reach goal. Okay. Now question is, so remember those three things क्या था भाई? Fringe, expansion and एक और था कुछ, whatever it was. Okay. So वापिस आ जाओ. अपना एल्गोरिथम क्या है? You are given a search tree. Search tree में you are going to expand nodes. Fringe का काम क्या है? Why do you have this fringe? Because fringe is a data structure where you are going to maintain which nodes you are supposed to visit now, right? And the third thing was strategy, right? Because your fringe contains elements, but कौन से element को आप पहले you are going to expand? That's a question that is still there in front of you. एक strategy अपन ने कर ली है. What is that? DFS. Next one is BFS. So this is the tree corresponding to this. We have done this before. Okay. So how will BFS work in this case now? See, I start. So right now algorithm has not started. Now what happens? So S was there in my fringe initially. Now once you expand S, then fringe becomes DEP, right? Now what will happen next? D, expand D, my fringe becomes BCE. All right, what happens next? All right, so done. So at the end of one level, what will be there in my fringe? If let's say if I have exhausted level L, what is my fringe now? All nodes at level L plus 1, right? Okay, so now I think things are easy. You keep on doing this. DFS was taking us to which node? Which goal? This one. Now BFS is taking us here. Is this the best goal? How do we know? I mean, up in the tree. If a goal is there up in the tree, does it mean it is the optimal goal? No, it does not. Right? So it does not until you tell me ki sir, if all weights are same, then that guy is optimal. So in which case BFS will give you the optimal solution? When all weights are same. So in that case the shallowest goal will be the goal that you are looking for. Does it make sense? Right? क्या चीज? देखो 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 दोस्त, DEP ये आप एक्सपेंड कर चुके हो, राइट? नाउ यू हैव दिस एज फ्रिंज. Expand this whole thing again. D expand होगा. D? S expand होगा, X से D E और P हुआ. Right. फिर D expand होगा. Right. तो फिर B C E और E दो बार होगा क्या मतलब? In this raw thing, yes. Right? Because I have a path here, I have a path here. So this path will be different and this path will be different. So E, even though it is the same, but this is at second level, this is at third level. So this gives me a different path, this gives me a different path. For my purpose right now they are different. Okay, because right? Next. So does this make sense that we will go to this G first? So that's it. Will algorithm stop? You find one goal state, algorithm stops there. Time complexity. This helps? No. This tree helps? Yes. Time complexity for BFS? Easy, you will be able to tell me. B to the M, because in the worst case my goal state will lie on the leaf. Okay. Now, but if my goal state lies in level S, B to the power S, right? So this is straightforward. So process all nodes above shallowest solution. Let the depth of shallowest solution be S. So in that case, such takes B to the S. If S equal to M, then you have B equal order B to the M. So this is easy. How many of you are not okay with this? एक बार बताना मेरे को. देखो, it's okay for me to be dead slow, but बता दिया करो कि कुछ समझ में नहीं आ रहा है. Okay? क्लास भी आओ और समझ भी नहीं आए, it doesn't make sense. हाँ. B to the S. Is B to the M fine? When will my time complexity be B to the M for BFS? When goal state lies in the last level. But if some goal state lies at a level S, will BFS go and explore further? It won't. Okay. How much space does the fringe take? Space complexity now. Time was easy. सोच के बोलना. देखो मतलब बहुत जल्दी आंसर करते हो आप लोग. B to the S minus 1. Okay. right? सेम वो वाली चीज बनाओ जो अपन अभी अभी अपने बात की है इस बारे में, सो इट शुड नॉट बी दैट डिफिकल्ट. When I am here, how many nodes in my fringe? One. Next one? So when I am done with this, how many nodes in fringe? Two or B? Whatever my branching factor is, right? So B. When I am done with this, how many? B square. Alright? So it is increasing exponentially. So what will be B to the M? Right, b to the power m in the worst case when I have my goal here, right, but you can reduce it down to b to the power s if the shallowest things they work, but I don't think they talk about it. So how much space does the fringe take? Has roughly the last year, so order b to the s. देखो, I am okay with this if you talk in terms of m rather than s, right, because even worst case for s is m. So, oh, by the way, is it complete? Because in the end, since it goes and searches everything, so eventually it will reach to a goal state if it exists. Remember, important statement here is completeness already has this thing in its definition that if it exists. So completeness आपको क्या बोल रहा है? आपको ये नहीं सोचना है कि नहीं है. Completeness says कि अगर गोल है, if you can reach, then it is complete. एग्जाम में ये प्रॉब्लम होती है एक दो जगह. Is it optimal? We have seen it is not, but in one case, when all costs are 1, then basically my shallowest solution is the one that I am looking for. Okay? All right. So when will BFS outperform DFS? We know. We have already talked about it. When? Right. And when will DFS outperform BFS? नहीं, give me a hypothetical situation कि सर ये हो जाएगा, then this will outperform this, and in other case this will outperform this. We have talked about this so many times before. When and this one when your goal is on the left hand side, right? So whichever side you are exploring. Okay, so we start this. एक बार Which one is this? I do it again. Again. Okay. Okay, so and let's say we go to next. So now we can clearly tell pehla wala was BFS and this one is DFS. Okay, because you know. Okay, so we are done with BFS and DFS. Now you should be able to tell me what is this algorithm doing. Iterative deepening. So what was the problem? So we have talked about good things of both, but what are the problems of both BFS? They both are super bad in the worst case, right? If you happen to be lucky कि भाई ऊपर ही कहीं पे है goal, fine, but then probably you won't need to work that hard if finding goal was that easy, right? So in most of the practical problems they will be of no use. Now idea is to get, okay, in terms of complexities, what was good for whom? So what was time complexity and space complexity? Time complexity was better for DFS or BFS? BFS? Worst case same है, right? But if shallower, then maybe BFS, maybe. Okay, so maybe. All right. Next, what about space complexity? Space complexity में कोई question नहीं है, because that was B into M. Another one is B to the power something, right? So B into M is certainly good. So what is this algorithm doing? Idea is to get DFS space advantage. DFS space advantage, which is B into M, and BFS time shallow solution advantages. So run a DFS with depth limit 1. What is this algorithm asking you to do? Run a DFS with depth limit 1. If no solution, run a DFS with depth limit 2. If no solution, run a DFS with depth limit 3, and just keep on doing this. Isn't that wastefully redundant? So generally most work happens in the lowest work, so right? So we don't really get that much speed up. But if you are running DFS at the last levels, right, you are still doing only as bad as that. Okay, so generally most work happens in the lowest level search, so not so bad. Next, what happens in this case now? So BFS finds the shortest path in terms of number of actions. It does not find the least cost path. ये बहुत लोग गड़बड़ करके आते हो कि एग्जाम में. We will now cover a similar algorithm which does the least cost path. अभी तक अपने इसमें weights नहीं थे, now we have weights. Yes. Okay, what do we do? This is an important algorithm. Okay, uniform cost search. Strategy changes again. I have not concentrated on iterative deepening at all. strategy is to expand the cheapest node first. So from the exam perspective, you can say BFS, DFS, UCS, but you should know about iterative deepening as well. So strategy is to expand the cheapest node first. Fringe is a priority queue. All right. So how do we start? S is in. नहीं, you tell me what will happen. एक बार थोड़ा सा try करो. Maybe 30 seconds. See, cheapest nodes means for BFS everything was equally cheap or equally expensive. Okay. So in this case, we start with of course root. We expanded P because cost is 1. Okay. So अब मेरी fringe बताओ. So okay. Next D because see this was 1, now this is 3. Next. So अब मेरे को cost 3 से ऊपर but 9 से कम. So whatever that is. Okay. Next. And you know. So we have reached here and DFS में लेवल्स कैसे बन रहे थे? लेफ्ट मोस्ट साइड से. BFS में लेवल वाइज, राइट? इन दिस केस अकॉर्डिंग टू दी कॉस्ट, राइट? सो इज दिस फाइन? Uniform cost search properties. Now again the same questions. So let me give you all these things and then maybe I'll hold these two things. ये तो बताओ पहले. So process all in the worst case. Give me the worst case for UCS. Right? Can you still go to the last? Right? Can you still have to search everything? No? In which case no? Right, but bring the worst case ekdam, right? But you are right ki it looks ki in general there will be some speed up. Process all nodes with cost. So you know if your solution lies on the last level and you know there is only one solution, last level, so there is only one best cost, so that is a super worst case. What nodes does UCS expand? Process all nodes with cost less than the cheapest solution. If that solution costs C star and arcs cost at least this much, then the effective depth is roughly C star by E. It takes time order B to the C star divided by E. What does this tell you? Just this. बाकी सब एक बार छोड़ दो. What is this telling you? That it is still exponential in my depth, right? So you might have some average case speed ups, but in the worst case it is still as bad as the other two. How much space does the fringe take? See in which way you are expanding, it's more like BFS, right? So space something of that kind only. What about, is it complete? Assuming best solution has finite cost and minimum arc is positive, yes. Is it optimal? Yes. Is it optimal? ये बताओ क्यों? What is the best case? Sorry? नहीं, एक बात बताओ, अगर गोल एग्जिस्ट करता है, हाउ इज यूसीएस गोइंग टू वर्क? सबसे कम. सो कैन यू हैव दिस कि you are expanding a node with cost 9 and goal was at 7. Can this happen? You are right now expanding a node with cost 9, but goal was having cost equal to 7. Can this happen for UCS? This cannot. So आपको जो पहला goal node मिलेगा, you might be having more than one goal node in your search tree, but the first goal that you will encounter, which will that be? The one with the least cost, right? So it is certainly optimal. What is this part now? What happens in case of minimum arc? So what happens in case of negative arcs? So why is it saying assume the best solution has a finite cost and minimum arc cost is positive? बता सकते हो यार, मतलब आराम. What will happen if negative? So if this and this cost is minus 1, let's say cost is minus 1, A will ask you to go to B, B will ask you to go to A. You will have a loop if there are negative, right? So in case of, and this is this, what are the conditions on Dijkstra and all? Floyd-Warshall कर रखा है आप लोगों ने? Floyd-Warshall कर रखा है? चलो, leave it. In this case, if you have it negative here, you will have loops. That's why they are not allowed. Does this argument make sense? Okay. Remember, UCS explores increasing cost contours. The good UCS is complete and optimal. Okay. So UCS explores increasing cost contours. UCS is complete and optimal. Bad is explores option in every direction. No information about goal location, and we'll fix this soon. So can you help me figure out कि इसमें ये लोग क्या बता रहे हैं? See, level does not matter for UCS, right? You can be here, but you can be expanding before this node because the cost to reach this node is lower than the cost to reach this node, right? So this is some kind of BFS, but a sophisticated one, because now you are not talking about in terms of levels, but you are talking in terms of cost. All right, so cost less than 1, you do everything first, cost less than 2, less than 3, and so on. So you start from here and you expand uniformly. Why am I making circles here? Why are they making circles here? Because cost 1, everything is done. Cost 2, everything is done. It does not matter which direction, right? Cost 3, everything is done. And for this cost, you reach here, so basically everything is done. You can't hit a goal before. So if there is a goal here, you won't reach to this goal before this goal. Is that argument clear? Okay. यार इस स्थिति में I don't think I should take 4 to 5 वाली class, or is it fine? हाँ नहीं, I won't leave this board. हाँ अच्छा छोड़ो, ये नेक्स्ट क्लास की बात छोड़ो, अभी इधर देखो. हाँ, विच वन इज दिस, राइट? एक बार और, एक बार बताओ, इन विच केस यूसीएस इज सेम एज बीएफएस? UCS is same as BFS. Cost is same, you are going to expand exactly in this fashion, right? Okay. Have I run the same thing? Okay. पहले तो कलर्स वगैरह को समझो एक बार. You start from here. What might this light blue mean? Low cost, right? And what about this dark blue? Higher cost. Okay. So what is this doing? Shall I do it again? So you are expand वापस. So let's say you have something like this, that this blue region, light blue region means, let's say cost is 1. To go from here to here, let's say cost is 1. But if you go from here to here, let's say cost is 2, something of that sort. Okay. So cost to move is higher here, lesser there. So it turns out to be this one. Now next. Now what has happened? Same thing again. So what is happening in all these three animations? So पिछली वाली मेज में if we see, एक बार मेज में डिफरेंस देखना. Okay. Is maze the same? No? देख लेना भाई एक बार. Okay. So let's guess which one. This is BFS. Right, now it makes more sense. This is BFS. Why? In terms of? It goes to the shallowest node first, right? Shallowest. Now this makes more sense. Maze is the same, right? This is UCS. Why? Now things make more sense, right? So now this makes more sense. Earlier was not making sense. So shortest path here now in terms of cost, but this was shortest path in terms of the number of steps taken. Okay. Any questions? Any discussions that we want to have? Next, let's see. And DFS, it always tells you that I am DFS, right? So, by questions here, because I don't want to start the, or I may have to. So all these search algorithms are the same except for fringe strategies. Conceptually, all fringe are priority queues, that is collections of nodes with some attached priorities. Practically for DFS and BFS, you can avoid the log n overhead from an actual priority queue by using stacks and queues. can even code one implementation that takes a variable queuing object. What does this mean? Search operates over, so is this fine? All the three things that we have done, DFS, BFS and UCS, they are basically the same thing. The only difference is how are you taking out the nodes to expand, right? So how are you emptying the fringe? That's what makes the difference. And what is this? Practically for DFS and BFS, you can avoid the log n overhead. Everybody knows priority queue here? How many of you know priority queue? I'm not going to ask you. I just want to know my audience. How many of you don't know priority queue? Okay. Was it taught? Okay. Alright, so you have this log n overhead because why would you have this log n overhead for priority queue? Right. Okay. Once you take the best one, you have to rearrange that. But in case of queue and stacks, you just don't have to do that. That operation happens in order 1. Can even code one implementation that takes variable queuing object. So search operates over models of the world, and we have seen that the models are just to represent the real world. They are not the exact replica of the world. The agent doesn't actually try all the plans out there in the real world. Planning is all in simulation. Your search is only as good as your models. So if your model is capturing your problem, then fine, but your search inherently can't improve the whole search, because if model is bad, search is not going to be better than what am I modeling. Okay. So these are the बहुत पुराने टाइम की चीज़ें हैं, 2005. This is still when Google Map or these kind of maps were being designed. Which path it is telling you? So this is the path, normal one. But right now in this case it is telling you a path जो किसी के घर में से होके फिर किधर से जाके, right? So search gone. Why this slide? Just after this slide, you are, so in case of mapping, what are you trying to model? You are वो तो बहुत बात की बात है. पहले आपके मॉडल में क्या होगा? Path, right? So all paths in my model should be actual paths in real life. If I have a model in which couple of paths are such that they are not there in real life, then you will have issues. This was still fine. What about this one? So start is in Norway, end is in Norway, but the path taken is you cross this sea by car, then again, then come back and then you reach here. Okay. Estimated total time 47 hours and 31 minutes. So it assumes कि C भी आप cross कर लोगे. Okay. So but ये पुराने दिनों की बात है. Sorry? Because your model was not right. So let's say, so in this might happen only when, let's say, something like this, that you don't have path from here to this side at all. So let's say if there is no direct path from here to, so let's say if there is no direct path from here to here, for whatever reasons, okay, These are weird reasons, so इनमें इतने ज़्यादा मत जाओ. But here to here there might be a path because let's say people take their cars. So this is what this happens here. People take their cars through cruise. So maybe that path happens and okay. But this slide was just to demonstrate one thing, that your search is only as good as your models. If in models we are capturing something wrong, then search will have that inherent problem. All right, so we still have time. By the way, attendance. चलो 5 मिनट पहले तो याद आ गया. So we'll do their projects only. If you go to the 2024 version, project 0, 1, 2 and 5 is I think we can do. नहीं, so उसमें कुछ ऐसे भी हैं, that part we will not cover. Okay. All right, so informed search, heuristics, greedy search. This is a super important algorithm, A star. Okay, and आगे you will see lot of games it has applications. कौन कौन से games में application लगा सकते हो A star की? So let's say Candy Crush. How can you use A star there? Everybody knows Candy Crush here? हाँ. So A star is a search algorithm. Much more improved version of BFS, DFS, actually much more improved version of UCS. Let's say you are designing Candy Crush. So एक बार इसको छोड़ते हैं. You are designing Candy Crush. कैसे करोगे? Ever wondered कि यार इसमें से सारी चीजें ऐसे ही कैसे गिरती हैं कि there exists a solution? भाई आपके पास एक प्रॉब्लम आई है. This is my initial configuration. What is that for us? Start state. What is the end state? Whatever task was given to me that happens, right? सारी jellies फोड़नी है, जो भी करना है. In between जो भी हो रहा है, does it happen the same for all of us? भाई किसी ने orange candies crush की हैं, तो किसी ने let's say green. Next screen will be different, and you think this will happen. कोड करने वाले ने exhaustively कोड किया होगा कि अगर, do you think it's a code of if else statements? कि if these three are crushed, then this will be my next state, this is what should drop down and so on. That becomes too cumbersome. So how will these things help you? Make sure that there is a path from start to end and it is achievable and so on, right? A star has a lot of applications.